So next, I want to hand it over to Malte, who is going to talk to you about AMP's anatomy.
Yeah, thanks all for coming. My name is Malte. Whoa, I can't forward slides. What's the gear? Cool. Yeah, so I'm like cramforce on the internet, and I'm the tech lead of the AMP project. That, in Google's terms, is for like I used to write all the code, and now I go to meetings. So just a quick recap of what AMP is. So, this is this race, and there's hand-tuned sites, and they're going to win, right? So AMP is not faster than what you can do if you really know what you're doing. And then there's the, AMP site is the fast follower. So it's definitely not as fast as a hand-tuned site, but it's always going to be pretty fast. And unfortunately, we have all like the average mobile sites back in the back, and as Paul, the Pauls said earlier, we're mostly talking about like static content media sites. This is, it's not about apps. But the important part about AMP is that like all the AMPs are expected to be like winning, right? They might not be the fastest, but they're all like up there. They're all going to be pretty fast. And so it's your fast track to rail. I had to put this in there to give some context. So yeah, all AMP documents, they should be decently fast, right? That's the promise. And the other thing is that AMP documents are only valid if they don't contain things that might be slow. And this is it's an important trade-off, because if you're the top-notch developer and you're super good at hand-tuning performance, there might be things that AMP documents cannot contain that you might be able to still put in a fast site, right? So it's a big trade-off, and there's definitely things that that we can't have, and that's like it's too bad. So what I'm going to talk about today are 10 things that AMP documents cannot not have, right? So and that's what this validation part is all about. So when even if you put a 10 megabyte JPEG on your page, right, then the AMP document is going to be slow, right, because there's a 10 megabyte JPEG on it. But it will still have every single optimization I talk about today. So we heard this before. So all external scripts are async. Like if an AMP document has a script tag on it and doesn't have an async attribute on it, then it's not a valid AMP document. And so what you'll find in every single AMP document is this one script tag that points to, it's currently called v0.js file from our CDN, and it must have this async attribute on it. So that's pretty simple. I think that's pretty straightforward, and people can do it. The second thing I want to talk about is static resource sizing. So people sometimes misunderstand this, that we mean fixed size, right? So 400 by 300 pixel, that's not what we mean. It can be totally responsive, but you need to be able to determine how big the thing is going to be without downloading the thing. So typical web page, this is an actual AMP file from The Guardian. The Guardian, basically the only known media site where there are non-AMP files actually faster, because they're awesome. But so this is, I kind of condensed this to wireframe. So you have like the header and the logo. There's often this like responsive hero image. There would be a headline. There would be the article, main text that has an image. Zooming further out, you might have an ad. Would have some more text. And in AMP, every single one of these boxes can be determined in size without downloading the resource, right? And so you've probably all seen this effect where you like load the page and it's too slow, and then you scroll down, and suddenly some ad on top decides that it wants to load and jumps everything down, and you just lose the line you were reading, and that's incredibly annoying, and it just cannot happen in AMP, right? So that's like it's an invariant of the system. This will never happen in AMP. And so we actually go a bit further. So AMP has an extension mechanism. So Paul was showing earlier that AMP files can have tweets in them, right? And not all AMP files will have tweets in them. So you have to like specifically download them as an extension. So the way you do this is, and here I use this AMP iframe thing. So you put this extra script tag that says, I'm going to, download the iframe implementation, and we actually require this custom-element equals amp-iframe thing on it. And what this does is it tells the AMP system we will eventually have the amp-iframe tag, right? And so there's this API in the browser, document.register element, that you use to register custom elements. And it will do this immediately before downloading the implementation. And because the sizing algorithm is independent of like what iframes are or what tweets are, we can make the box before we even know what amp-iframe is, right? So it goes to the absolute maximum that only the initial amp script is known, needs to be downloaded to lay out every single thing on the page. So even the extensions are not subject to like blocking the page. And what that leads to is that we need exactly one HTTP request to lay out the entire doc. If you have custom fonts, those, depending on how you integrate them, would still block. But basically, it's the fonts plus the document, and that's all you need. We've heard this before as well. So we do allow third-party JavaScript, but only in custom and only in sandbox iframes. And that gives us a few benefits. So first of all, I mean, third-party JavaScript typically does atrocious things. So what they like to do is they like to use sync JavaScript loading. And the next thing they like to do is they like to document write another sync JavaScript tag from the sync JavaScript tag. And then that typically likes to document write another sync JavaScript tag. And so if you have, for example, 5 ads on a page, and each does 3 sync loads, and you're on a 1-second latency connection, you're suddenly to something like 18 seconds of load time just for JavaScript loading. And that's really quickly. And so by banning them into these iframes, they don't block execution of the main page. So even while they might still be as terrible as they ever were, they at least don't mess up the main page loading. The thing is also, they might do like all these style recalculations or really expensive layouts, but because they're in these tiny iframes that don't actually have any DOM, like basically only the body tag, those operations, because they're typically linear to DOM size, they're really fast in comparison. Next thing is CSS portion control. So the thing is that there isn't yet a good solution for knowing what part of CSS a particular page is using, right? So what people typically do is they have maybe 1 or 2 large JavaScript CSS files or one big one. And the thing is that CSS, first of all, blocks all rendering because you need the CSS to render because it says like how to render stuff. And so it's blocking page load, and it tends to get really large. Like often sites degenerate to like dozens of kilobytes to like a megabyte. And so what we decided would be that first of all CSS must be inline, and it must not be bigger than 50 kilobytes. And so how did we come to 50 kilobytes? So from our testing, which means we made web pages, we found that it's basically large enough to make a very, very sophisticated page. It's not large enough to make a sophisticated site, right? So it forces people to say, like my article page, like what CSS do I actually need, and make that decision. So it forces hygiene, and although I kind of, hygiene takes time, but it's really important. So I think this actually is one of the largest performance improvements in AMP, that there's a size limitation on CSS. And originally, we actually had lots of limitations on what you could do in terms of CSS selectors. But because really, all the CSS matching stuff is linear in complexity, and if you don't have as much of it, it just doesn't take as much time. We basically took away most of these things. And now you can do essentially everything you want in CSS. You just can only have 50 kilobytes of it. So yeah, now I'm going to talk about fonts. So if all we wanted to do was make like the fastest web pages in the world, we would just have said like no fonts, right? Because fonts tend to be pretty big. Like it's very common that like a custom font would have like 200 kilobytes, 300 kilobytes post gzip, and because typically you want the fonts to be there when you lay out the page, they're kind of blocking. And we as web developers, we learn, for example, there's a thing called preload scanner, and it goes through the page, there's blocking script, but it doesn't fully ignore them and says like, oh, there's an image, let's download the image because you probably need it. And I think like me personally, I had this, what I found reasonable expectation that that's how fonts work, but they don't. So just because you say font face in your CSS file doesn't mean the browser will download it. The browser wants to know that the font is actually used on the page. So because sync script could like document write and like totally change the page, they have to wait for those to download the font. Because external style sheet actually determine what CSS rules match on the page, they have to wait for all of them to even start downloading the font. And that means that on a typical web page that will have a few sync script and it will have a few style sheet, the time when we actually start downloading these large files is basically when we would be ready to render. Like, and the only thing that's missing is the freaking font, right? And so that's really sad. And that is, why we decided we must do better in AMP. And in AMP, there's 0 HTTP requests needed to determine all the fonts that might be needed. The downside is that we had to invent this atrocity. So one of my original goals in AMP was I wanted to make the HTML idiomatic. Right? I wanted to make the HTML to look like something like a reasonable person would write when they just came up with it themselves. And a reasonable person would not put this style tag on their page because it's unreasonable. But what it does basically, it hides the body. There's a no script stuff so that if if there's nothing ever to unhide it, it's not hidden. But it hides the body, and then the JavaScript will unhide it. And because all the scripts are async and the body isn't hidden, the browser can go match the styles, see what fonts are needed, because the CSS is inline, all the scripts are async, so they don't block. So it goes and downloads all the fonts. Because it would render now, and the fonts aren't there, the page would look ugly, and also AMP hasn't maybe not loaded yet, so the page is ugly, so we hide the page, right? And so this is very unfortunate. But it comes to this effect that font download is independent of any other HTTP request, and you don't get this effect of like flash of unstyled content. So there's a problem with this opacity hack, and that is if the AMP JavaScript library times out, because Google's servers are down, which happens every 2 years, but it happens. The page stays completely blank because no JavaScript loads ever unloads it. That's a problem. Fortunately, my colleague had this, I think, amazing idea. I call it the CSS hack of the year. So what we're going to do is we're going to change this to use a CSS animation to simulate a timeout. So what we'll change this boilerplate to is this, where basically we'll say, we'll hide the body, but we'll set up a CSS animation that will unhide the body. I made up 5 seconds. Maybe that's not a good value. But basically, when the JavaScript comes first, it will unhide this, and the animation doesn't matter. But if the JavaScript never comes, the CSS animation will fire and will unhide the body. So we get basically this world of great, fast font downloading and no dependence on the successful loading of any external JavaScript. Cool. So the next thing is minimal style recalculations. So one of the important aspects of AMP is it controls when things change their size, right? So right now, actually, that only really happens when you resize the window or when you change the orientation of your phone. And AMP knows that when it ever measured that this thing is here, it will probably not have to remeasure, right? So it doesn't have to force these hard layouts that are really expensive. And the next thing that AMP is using is there's a library called fastdom that does the same thing, and really that's the big win. So if you're not using fastdom or something like it, that is really making websites faster at scale. And what it does is it batches DOM access. And I'm just going to show some examples. So this is a very common pattern. And obviously, this is reduced. So but imagine there's 3 function calls. And it's really hard to say that they do something very, very bad. So they go and measure something, right, which is reasonable. Then you change the DOM, which is also reasonable. Then you measure something again, which is again reasonable. And then you change it again, and you measure again. And what happens here is that each time you measure something, because meanwhile the DOM changed, it triggers this style recalculation. And those are really expensive because basically the browser has to lay out the entire page or at least some subgraph of it. So that's not what you want. And by batching DOM access, you come to this. Basically, what fastdom does and what we do internally in AMP is that when you do a read, it gets scheduled. And when you do a write, it gets scheduled for the next animation frame. And all the reads happen first, and then all the writes happen. And because all the reads happen first, there's no nothing can have changed immediately, so there's no recurrent recalculate style. So you get a max of 1 recalculation of styles per frame, which is really the only thing you can afford if you ever want to get to 60 frames per second in a browser. And so arguably after Paul Irish and us did like kind of this performance audit on AMP, we kind of went all in. And so now when you load an AMP page that doesn't have any external script, it will do 2 style recalculations on load, which is, if you compare that to what a normal page would do in the wild, that's very, very low count. Next topic. So every modern device has a GPU, right? And the only way to do fast animations is to run them on the GPU. There's just no way around that. And so we made a very tough decision. So AMP allows animations and transitions, but it only allows them on transform and opacity. So the reason is that when you see what does a GPU do, right? It knows about layers, and it knows how to perform things on these layers. It can move them, and can fade them, but it cannot. What it cannot do, it cannot lay out the page. So if you change the width of something in an animation, the GPU says oh, I give up. Browser, do make me a new layout, right? If you change the transform, it says that is actually an invariant operation to page layout. I totally know how to do this. I'm just going to do it for you, and it's going to be extremely cheap. So that's why basically we limit ourselves to these 2, and this applies to user code. And so you could do this animation, but you cannot animate width and height. And obviously that's it's a big trade-off, right? We're aware of this. Sometimes it's nice to animate other properties, but it's not allowed. And so that gives this baseline performance guarantee that everything you do in terms of animation will be decently fast. Cool. Now I'm going to talk about resource prioritization. So and again, we've heard about this before. Again, coming back to our wireframe model. So usually not everything on a page is visible at the same time, right? I mean, this might be a tablet kind of screen, and in the first viewport you have kind of the logo and the responsive hero image and the headline, but you don't see much else. And so what AMP tries to do is generally to download things that are likely to be seen. That's many of you probably have done kind of endless scrolling kind of things that kind of load things as they go. So AMP kind of does the same thing on the regular page. So it optimizes obviously for resources currently in view, and in terms of prioritization, we definitely prioritize ads slower than everything else. That's actually pretty extreme right now in AMP. We might tune it back a little bit, but basically what we want to my goal really is, I shouldn't say this, that AMP pages load faster when you have no ad blocker. Because ad blockers are slow, they have to scan the DOM. So because we load the ads later, they don't really affect page layout because they can't make you jump around. It's the ad comes later, but whatever, right? So it at least doesn't make you it doesn't annoy you. And we also, by the way, don't allow ads to be in position fixed. So you cannot actually make full page overlays, which I'm excited about. So yeah, but that's kind of the baseline thing. Also, I'd like to talk about, this is actually an interesting topic, why wouldn't a browser do this? And I think, so it's important to understand you cannot use AMP to build apps, right? You can load AMPs into apps, but AMPs are only for these relatively static pages. And so we know exactly what we need to optimize for, right? So if Chrome would decide to not download stuff not currently in the viewport, that might not be the best kind of behavior for some kind of web app that's very sophisticated and that totally wants to control what's in the other pages, other orders of the page. So that's why basically AMP can make these decisions that just wouldn't be generically applicable enough that a web browser could do it. I mean, I think that might be one of the things that might eventually come back to browsers. So for example, if you have like schema.org markup on your HTML text, and this is an article, like the browser could maybe like go into this special mode for articles and do a better job. But like I think it's great that we can experiment with what a great strategy is, and eventually maybe browsers will do the same thing. Cool. So finally, I'm going to talk about instant loading. You saw this in Paul's demo. So everything I talked about so far gets you to that magic 1 second, right? It doesn't make it so that you click something and it's already there. Like you only get that with cheating, and so with pre-rendering, obviously. Browsers had for a long time the link rel pre-render tag, right? So you can basically say, hey browser, render this other page. And when the user navigates to it, it's already there. It's instant, right? It's pretty simple. There's some problems with it. That other page might use essentially arbitrary CPU, right? So the other page might have a while loop in it. While true, go run JavaScript, take all the time you can get, and that might totally crush your device. The other thing is that that other page might be like full of images, right? BuzzFeed post, 15 Instagram posts in it, and the browser, if you pre-render, will download all of them, right? Which might be very expensive. So, and this is where AMP gets and makes this like very different. So basically, AMP will see like what is the first viewport, and when it's in pre-render mode, it will not download anything that isn't in that viewport, right? And so this this image here, it will not be downloaded. Right? It will eventually be downloaded when you actually go to the article, but for now it won't be downloaded, and it won't execute any third-party JS. So if that page has an ad, if it has some kind of analytics, if it points to some iframe, if it points to some tweet, if it points to some Instagram post, none of those will load, right? That typically doesn't really matter because you still have the headline, you still have the hero image. You kind of get this impression, the idea of the page, and because our layouts are static, that we didn't download that stuff doesn't really change much throughout the page. And so that we download no third-party JS because AMP JavaScript is kind of like it's optimized and it's really small. You get this pretty constant cost of CPU. And because we only download the stuff you can actually see when you first open the page, you get basically this trade-off where you get essentially 75% off pre-rendering for AMP. And what you need to understand with pre-rendering is pre-rendering means we might display that page, right? We don't know. And so we guess. And guessing is hard. But guessing if you get 4 guesses, like it's much more likely to be true. So imagine a search result page. Sure, people click the first result, and that's probably the best guess you can make. But if you get to guess the first 4 results, it's very, very likely that the user will click this, right? And so you get this much higher fidelity of many, many more actual renders will be pre-rendered. And that's really what this is about. That's why our demo works so well, because we can actually like almost typically when you click something, it's already done, and that's instant because it's actually already done. So yeah, so we only download the first viewport, but humans, like we haven't talked about perceived performance enough tonight, but speed is about perceiving speed. And as I said, we only like download stuff on the first viewport, but when that comes up, we can then start downloading everything else on the page. And until you actually start scrolling, until you have read the headline, by that time everything else is already done, right? So the actual effect is essentially perfect, even though we really just cheated, right? We only downloaded the stuff you saw first, but that's everything that's needed. Cool, so this was my 10th point. Just gonna run through these elements again. So again, what I want to emphasize is that everything I talked about today, first of all, it might apply to your website, and you can use this, right? But if you use AMP, you cannot not have this. This will always be true. So it will only be async script. All the resourcing is sizing is there. The extension mechanism doesn't block rendering. We do allow third-party JS, but it's out of the critical path. The CSS is all inline, and it's bound in size. The font triggering is very efficient, and we have a GitHub bug about giving people a bit more control about font rendering. I think that's really important. Style recalculations are minimal. Everything in terms of animation and transitions will be GPU optimized. We prioritize resources, and then we do the efficient pre-rendering that gets you instant loading. That's all I have. I was in New York this week. I made pictures. Thank you.